In this notebook, I'm explaining experiment 3. So for the linear regression questions, the first question, I have imported the data set. And for the second question, I have performed data cleaning to find the missing values and replace them with the mean. Dataset may contains missing values. Missing values can affect model performance, so they must be handled before analysis. The dataset is checked for null values. If the missing value exists, they are replaced with the mean value of the respective column. This process is called mean imputation. And for the third experiment, we have chosen independent variable x as sepal length cm, dependent variable y as sepal width cm, and the independent variable is used to predict the dependent variable. And for the fourth question, I have computed the regression coefficients B0 and B1. So the equation for the simple linear is y is equal to B naught plus B1x, where B naught is the intercept, B1 is the slope of the regression line. The slope indicates how much the dependent variable changes when the independent variable increases by 1 unit. These coefficients are calculated using the mathematical formulas. For the fifth question, I have formulated the equation for y pred and calculated y pred. And after computing B naught and B1, the regression equation is formed. Y pred is equal to B naught plus B1 into x. Using this equation, predicted values of the sepal with the cm are calculated for each value of sepal length cm, and you can see here as in the output. And for the sixth question, I have calculated the sum of squared error value. So SSE measures the total difference between the actual values and predicted values. A smaller SSE means the regression model fits the data better. So this is the SSE. And for the seventh question, I have calculated root mean square error. So RMSE measures the average error between predicted values and the actual values. So I have used the formula RMSE is equal to root SSE by n, where n is the number of the observations. Lower RMSE indicates better prediction accuracy. And for the eighth question, I've calculated the coefficient of determination R square. The coefficient of determination R square measures how well the regression model explains the variations in the data. R square value ranges from 0 to 1. So value close to 1 indicates a strong model. Value close to 0 indicates a weak model. I've calculated here the R square. And for the ninth question, I have plotted a regression line along with the given data points 7 and 5. A scatter plot is created using the data set. Data points represents the actual observations. A regression line represents the predicted relationship between the variables. The visualization helps understand how well the model fits the data. And for the 10th question, I have predicted the y for any given x value. Once the regression equation is obtained, it can be used to predict the value of sepal with cm for any given value, sepal length cm. This is the main purpose of the regression model. So for x, 5.5, I have predicted y is equal to 3.0761, so on. And for the multiple linear regression questions, the first, as usual, I have imported the data set. And for the second question, I have performed the data cleaning to find the missing values. The null values are replaced with the mean of the column to ensure accurate analysis. And for the third question, I have selected x1 is equal to sepal length cm, x2 is petal length cm, dependent variable y is equal to sepal width cm. Multiple linear regression uses more than one input variable to predict the output. And for the fourth question, I've computed the intercept and coefficients. The multiple regression equation is y is equal to b naught plus b1 x1 plus b2 x2. B naught is the intercept and b1 is the coefficient of the sepal length cm. B2 is the coefficient of the petal length cm. These coefficients determine the contribution of each variable to the prediction. I've calculated the intercept, this coefficient of b1 and coefficient b2 in the output. And the fifth question, using the coefficients of predicted value is calculated. Y pred is equal to B naught plus B1 into X1 plus B2 into X2. This predicts sepal with CM using both sepal length CM and petal length CM. You can see in the output. And for the sixth question, I've calculated the sum of squared error. So SSE measures the total square difference between the actual and predicted values. And for the seventh question, I've done root mean square error. And for the eighth question, I have calculated the coefficient of determination, which is R square. R square measures how well the independent variable explains the variation in the dependent variable. So a higher R square means the regression model explains the data better. And for the ninth question, I have predicted the y for any given x1 and x2 value using the regression equation, which is y is equal to b naught plus b1 into x1 nu plus b2 and x2 nu. The value of sepal with cm can be predicted for any given values of sepal length cm and petal length cm. And for the logistic regression question, same, I have imported the CSV file and I performed a pre-processing, which is a mean imputation and label encoding. In this, I did a two pre-processing technique, which is mean imputation and label encoding. Mean imputation is missing values are replaced with the mean of the column. Label encoding, the categorical variable species is converted into numerical values. And for the third, I've chosen independent variable sepal with CM, sepal length CM, petal with CM, petal length CM. Dependent variable, I've used species. And for the fourth question, I've calculated cost function and reduced it using gradient descent. Logistic regression uses a cost function to measure prediction error. Gradient descent is an optimization algorithm used to minimize the cost function by updating and model parameters iteratively. As the iteration increases, the cost decreases and the model improves. This is the final cost after the training. You can see it in the output. And for the fifth question, I have plotted the graph for iteration against cost. The x-axis is contains number of iteration, y-axis is the cost value. This graph shows how the cost decreases as the model learns. And for the sixth question, I have computed the accuracy of the model. Accuracy measures how many predictions made by the models are correct. So accuracy is equal to correct predictions by total predictions into 100. So a higher accuracy indicates better classification and performance. Thank you.